Hi friends, welcome back. Today we are going to solve another famous and popular Facebook and Google coding interview question on Leetcode 695 max area of island. As you can see from the like dislike ratio, another very popular and likable coding interview problem of medium complexity. So we are going to understand this problem today and we are also going to implement our Java solution to solve this important coding problem. If you are a fresher, junior level developer, mid-level developer planning to take coding rounds of interviews, then make sure you watch this video until the end so you completely understand the logic and the Java solution to solve this very important coding interview problem. So first we'll go through the problem statement, then we'll go through some examples, then we'll understand the logic as well as then we'll start implementing the Java code to solve this coding problem. So let's start. You are given m by n binary matrix grid. An island is group of ones representing land connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with a value 1 in the island. Return the maximum area of an island in the grid. If there is no island, return 0. So this is what the problem statement says. Uh, M is number of rows, N is number of columns in the given grid. M and N will be between 1 to 50. So 50 by 50 is the maximum size of the matrix and it contains 0 and 1s. It's a binary matrix. So let's take this example over here. So it's the same example. So they are saying that 1 is basically a part of an island, right, in this given matrix. So if you look at this particular example, then you will see that there are couple of islands here, right? So this is one island, this is another island, 1, 2, 3, 4, 5, and then 6, right? So there are 6 different islands as you can see here, right? Okay, so now one important thing is this is one island, this part is one island, okay? And this is another island. They are not one island, they are separate islands. Why? Because only they can be connected in four possible directions, which are up, down, left and right. Now this is not a connection, basically this is diagonal, right? So this is not allowed basically, okay? So they are separate islands, okay? So they have highlighted the maximum area island here, right, as you can see. So let's just visually look at this problem first. So this area is 1, right? You can just see one cell is there. For this island the area is 4. There are 4 connected cells, right? For this island, as you can see, the area is 5 here, right? 1 2 3 4 5 5 connected cells are there in this island. For this island you will see that area is 4 connected cells are there. For this island you will see that the area is 6, right? 1 2 3 4 5 and 6 connected cells are there. And for this island the connected cells are 5, right? 1 2 3 4 5. Okay, and as I said, this is not a connected island, okay, because diagonal connection is not allowed, okay? The connection should be vertical or horizontal, right? Okay, so now so just visually look at it, you understood that this is the maximum size of an island basically in the given grid, right? How can we solve this coding problem now? So now what we will do to solve this coding problems, we will use a very famous algorithmic technique called as BFS, right? We'll use breadth first search or breadth first traversal here, right? So BFS is also known many times as a level order traversal, right? And this uses queue. BFS uses queue to hold the information, right, and process it. So we are also going to use queue. So what are we going to put into that queue? So whenever we see a 1, right, whenever we see a 1, for example, we will go like this in this matrix, okay? We will go like left to right, row by row, like this, right? We will go like this, okay? And what we will do is whenever we see a 1, we will start putting this cell into a queue, right? So let's talk about this. So let's say we are processing this one cell, we found out this one, we started processing this island, okay? So we'll put this cell into a like this cell coordinates we will put inside the queue. Let's say this is the queue, right? This is the queue. And what queue is going to hold? Queue is going to hold two things, right? It is actually integer array, right? Because row and column of the cell it will hold, right? So for example, this is the row number 0 and column number 0, 1, 2, 3, 4, 5, 6, 7, right? So 0 comma 7 is what it will hold first. Okay, we'll put this into the queue. This is the starting point of BFS. We will put one count, right? Count will count how many cells we have processed. So count is 1 now, right? We put one cell here. We'll start going in 8 possible directions, right? So what are the 8 possible directions? So these are the, so I'll show you here what it, sorry, we will go in 4 possible directions, not 8 in this case, right? So let's say this is a matrix. This is a part of the matrix. Okay, so this is a part of a matrix. So if you are here, right, you are processing this cell I comma j is the cell you are processing. So you can actually these cells can be connected in island as up, down, right and left, right? These four directions, right? So up means what? I minus 1j, right? This is I minus 1j. This one is I plus 1j, right? Because next row same column, next column same row ij plus 1, right? And ij minus 1, right? So these are the 4 directions we will go, right? And then we will process all these cells if this is a valid cell. So what does it mean by valid cell? This cell should not be outside of the boundary of the matrix, right? It should be inside the matrix and it should have a value 1, right? Then only it is part of the island, correct? Okay, so now here, right? Okay, so now in this case what cell we will process? Up, down, right and left. So only one cell we will find out that we can process, this one, right? So we'll remove this cell and we will add this cell there, right? So its coordinate will be 1 comma 7, right? So we'll add this coordinate here, right? Count. Now next time we'll remove this cell 1 7 from the queue. We will increment our counter by 1. So now counter is 2. We will go in 4 directions and we will visit. When we are processing a cell, we will change it to 0. So we will process and we will mark it as a 0 now. Okay, so now we should not revisit that cell again, correct? So we will change it to 0. Okay, now again, now we are at this cell, we will go up, down, left and right. So now only right is a cell that we want to process, right? Up is already visited, left is a 0, right, down is 0, so we cannot process 0, it's not part of island. Right is 1, so we can process this right cell, right? So we'll go and process this right cell and we'll change this to 0 now. This one will be 0 and we'll add that cell into here, right? So 0 comma 8 cell we will add here, right? Okay, next time count, this cell will be removed from the queue, count will be increased by 1, right? And we will check in 4 possible directions, right? Up, down, left and right. So now this is the valid cell we'll find, right? So we'll process this cell. This cell will be changed to 0, correct? 0, and we will add 1 comma 9, correct? 1 comma 9 will add here. And next time we'll remove this cell, this one will be incremented by 1 4, right? And this is a stopping point. Now you convert it to 0. Now you cannot go any further, right? There is no connection now, all the cells are processed. So the count will tell you how much is the area of this island, right? We will keep track of the maximum area size that we have seen basically, right? Maximum area size. So in this case we will find out maximum area size will be 6, correct? For this island, you will find 6, right? Okay, so this is the approach to solve this problem using BFS. So I hope it is clear to you now. This is a Facebook Google coding interview question. So now let's go step by step through the code so it will be more clear for you. So these are the 4 possible directions which we are going to use. This is just a 2D integer array. So these are the directions that I shown you, right? Top, bottom, right and left, right? So I shown you this right here. So this is the same thing here. Okay, So max area of island is the method we are implementing. It returns maximum area integer, and we get a grid which is a 2D integer matrix, right? Only having zeros and ones. It's a binary matrix. We'll create a queue. Queue is going to hold integer array. That integer array hold two things, row and column for every cell, right? Okay, max area is a to keep track of the maximum area we have seen for any of the islands in the existing grid. It is 0 in the beginning. Now this is the for loops where we will start basically going through left to right, like this we are going, right? Left to right we are going. Whenever we hit a 1, we will start processing that as an island. Whenever we hit a 1, it is part of an island. We will process that island and we will update our area, maximum area. Whenever we find out a island area which is more than max area, we will update our max area here. Okay, and we'll return the max area at the end. This BFS is to calculate the area of the current island. So what we will put into the BFS, will input the grid which is given to us. Ij is the cell of the current coordinate, right? It is the it is the coordinates of the current cell, right? I and j, and q is the q, this q, right, is the linked list. Okay, now let's take a look at the BFS code. So this is a private method. So before we go through the BFS, I'll show you this helper method inside matrix boundary. So we get a grid and row and column here. So what inside matrix boundary does is it checks whether the current this row and column is a cell which is inside the matrix boundary or not, right? Because we want to only process the cells which are inside the matrix boundary, right? If it is outside of the boundary, then we don't want to process those cells, correct? So how we'll know that it's inside or not? If r is greater than equal to 0, r is less than grid dot length, c is greater than equal to 0, and c dot is less than grid r dot length, then it is inside the boundary of the matrix, right? Otherwise it is not inside. So it will return true or false. True if the cell is inside the matrix boundary. Okay, so this is the helper method we'll be using now here in this code. So this is our BFS code. So we get the grid, we get row and column of the current cell, right, that we want to process the island, right? And then we get a queue. Queue is actually just an empty queue basically, right? Empty queue. Now here count is 0. Count is to keep track of how many cells we have found out in that island, right? Which are having ones, right? Which are connected. For example, here we have found out 4 cells which are connected in this island, right? So that is a count. So first we will offer the current row and column to the queue, correct, as an integer array, because we need to have something to start with, right? So this is the starting cell to start the BFS, correct? The current the current cell, right? Row and column of the current cell. Now while queue is not empty, so this is a typical BFS implementation, right? While queue is not empty, we will start processing the queue, all the cells. We will read the current, we will remove the cell from the queue, correct? So we'll remove the cell from the queue. We are going to get two things from that current cell, right? The current row and current column. So current cell 0 is current row, current cell 1 is current column, right? Okay, so now we got current row, current column. Now we want to check if it is 0. If this is 0, the current row and current column, it means that it's already visited cell basically, right? So it's not, there is no point to visit that cell again, correct? Because whenever we visit a cell, we will change it to 0, correct? So we will just continue in this case, right? So you see what I'm saying? So once you visit that cell, for example, you start with this cell, right? Let's say you start with this cell. Once you process it, you will change it to 0, right? So you will not again process this cell. Again, when you process this cell, you will change it to 0, right? Then this one will be 0, 0, 0, right? So you will only process it once. So it is already processed. You will just continue basically in this while loop, right? Okay, so now let's say it's not processed, so it is 1. For example, its value is 1, right? Then you want to process it, so you will increment the count because you found out one more cell, right? So you'll increment the area count here, and you will mark that current cell as 0 because now you have processed that current cell, right? So you are changing it from 1 to 0 now because you processed that, right? So you are marking it as 0, which is processed now. Now you are going to go in 4 directions. These are the 4 directions we will go, right? For this current cell, you will go up, down, right and left. So that's what we are doing now here. So current row plus direction 0 will give you new row. Current column plus direction 1 will give you new column, right? And then you will get a new cell coordinate here, right? And then you will just add that new cell coordinate if it is inside the boundary of the matrix, and if it is 1, then you are going to add that into the queue, correct? You will add that into the queue because this cell is a good cell to process, right? So that it gets processed further through the BFS. At the end you will get the count. Count will tell you the number of the total area of that island, right? For example, here you will get count 4, right? So let me change the color. So for this island you will get count 4, right? For this island you will get count 6, correct? So this is what the count does. Count will tell you how many connected cells are there basically, right? So you got this point clearly, right? So this new cell that we have found, right, which is connected to this current cell, if it is inside the matrix boundary, we are checking here, if it is inside the matrix boundary and it is 1, right? If it is 1, then we want to process that cell, correct? Because it's a connected land cell, right? It's a land cell and connected to the current cell, right? In the 4 possible directions, one of the 4 possible directions, right? So you will add that new cell into the queue so that it can be processed further through the BFS, right? So this is how the code works. So I hope it is clear to you. It's just a regular BFS implementation. So we'll now execute this code. Make sure it gives us correct answers. For the first one, we are expecting 6 as the answer. So let's take a look. So we are getting 6 here. As you can see, expected and output is correct, which is correct answer. For the second one, we are getting 0 here. So we are getting 0 correct answer, right? So we'll submit this code, make sure it gets accepted by the Leetcode, and as you can see the code is successfully accepted by the Leetcode. It is almost 10% faster on the performance side and 6% faster on the memory usage. So this is the way you can solve this problem using BFS 695 max area of island, one of the Facebook and Google coding interview question. So I just wanted to show you the approach using BFS to solve this coding problem. This same problem can also be solved using DFS. So I'll also give you the link of another video once I create with DFS approach, so you can take a look at both the solutions. I'm going to add this Java solution in my GitHub repository and give you the link of this code so you can check it out. There are lots of other important Java solutions and algorithms already implemented and available there for you. If you want to take a look at more Java solutions and code, you can check out the Java solutions there. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, we have created a very important coding interview playlist for you to help you in your interview rounds. The name of that playlist is Leetcode and Leetcode Solutions. We have compiled more than 250 most frequently asked very important coding interview problems for you under one playlist there. Those are the coding problems that got asked by many big tech companies, including FANG companies many times in their interviews. Those are very important coding interview problems. You will see all different varieties of problems there, including graphs, matrices, binary search trees, binary trees, different algorithmic problems using depth first search, breadth first search, cadence algorithm, binary search algorithm, Prim's algorithm, Kruskal's algorithm, and many more important algorithmic problems. You will also find a lot of important data structures related coding interview questions explained with examples for you. For example, stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, as well as many more important data structures related coding interview problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn different concepts of computer science, programming, data structures, algorithms, problem solving, logic building and Java coding, then this channel can definitely help you in doing so. So please subscribe to this channel now. Also, click the bell notification icon button right away so you won't miss any important postings from this channel. We often create videos to help others learn how to solve different varieties of coding problems, as well as to help others in their interview preparation process by creating content that is useful for others in their interview preparation. If you like this video, if you like this BFS breadth first search based Java solution to solve this important coding problem max area of island on Leetcode, then please give it a thumbs up to the video, give a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people. So others will also be able to watch these videos and learn from these videos. So if you like this video, then do give it a like. Share this video with all your friends, so your friends will also learn more problem solving using different data structures, algorithms and different techniques. If you like the videos on this channel, if they are helping your learning process, you are learning new techniques here, you are learning more coding here, you are learning more problem solving and data structures and algorithmic approaches here, then mention that into the comments. Your comments and your feedback both are very important and valuable for us. That increases our motivation to create more quality content. So if these videos are useful and helpful for you, then do mention that into the comments and share it with all your friends. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process going on continuously. And thanks for watching these videos.